Good morning, student. Today we are going to solve the problem on centrifugal pump. So let us see one of the question based on that centrifugal pump. Here the question is given: a centrifugal pump has external and internal diameters of impeller as 40 centimeter and 20 centimeters. The blade angle at outlet is 30 degrees. Speed of the impeller is 1450 rpm. Velocity of flow at inlet and outlet is same, and the value is 2.242 meter per second. If the manometric efficiency is 75%, so then you have to find head developed, absolute velocity at outlet, and blade angle at the inlet. So this is the question, and before going to solve this problem, so let us draw the velocity diagram for the centrifugal pump. So this is the blade for blade or vane for the centrifugal pump, and this part is the impeller part, and this is the radius for inlet and the radius for outlet of the blade or impeller. And at this point water is entering, at this point water is leaving. So let us draw the velocity diagram at inlet and outlet. So this is the inlet velocity diagram. So v1 direction, that is absolute velocity of water, and blade velocity and relative velocity. So alpha is the inlet jet angle, and theta is the angle between relative velocity and blade velocity, that is simply a vane angle or blade angle, you can call it as. And coming to the second outlet velocity triangle, so velocity of the jet in this direction and blade velocity in this direction, so these two are joined with relative velocity, and this jet velocity is some inclination, so it's a flow this vertical component, and this is the horizontal component, that is vw2 and vf2 for absolute velocity. And this is the velocity diagram, so at inlet and outlet for the centrifugal pump. And coming to the question part, so see the given values carefully. So outlet diameter and inlet diameter, so outlet diameter is up to here and inlet diameter is up to this point. So that is outer diameter is d2 40 centimeters and 0.4 meters. Inner diameter is 20 centimeters, that is equal to 0.2 meters. Blade angle at outlet, so this is the blade angle. Blade angle at outlet is given 30 degrees, and speed of the impeller, so this speed of this impeller is 1450 rpm, and velocity of flow at outlet and inlet is same, that is vf1 is equal to vf2, that is equal to 2.2. so vf1 and vf2 both are same, the value is 2.2 meter per second, and manometric efficiency is given 75%. So this is the given values, and you are asked to find the values of head developed, absolute velocity, and blade angle. So this blade angle at inlet is nothing but a theta value, absolute velocity is v2 value, and head developed is h value, that is the height to be lifted by this pump, water to be lifted, whatever the position that is required to transfer the water, that is the head developed. So to find the head developed value, we can use the formula, that is manometric efficiency formula. So manometric efficiency equal to manometric head by work done by the impeller per unit weight of the water, that is equal to 1 by g vw2 u2, and head, that is manometric head is hm by 1 by g vw2 u2. So that g can be taken to upward, that is ghm by vw2 u2. So this is the manometric efficiency. Total 3 types of efficiency are considering in the in this pump, that is one is manometric efficiency, second one is mechanical efficiency, similarly overall efficiency. So by considering this manometric efficiency only, you will get the manometric, that is manometric head or head developed. So to find this value, manometric efficiency, vw2 value, u2 value, g value should be known for us, but the value manometric efficiency is given in the question. vw2 and u2 value are unknown, and g value is constant value, so we have to find vw2 value and u2 value. So to get vw2 and v2 value, where is the vw2? So this is the vw2 value, and this one is the u2 value. So those you have to find. To find the u2 value directly, the tangential, this is the tangential velocity at outlet, so we can use the formula pi d2n by 60. So this is the direct formula for finding u2 value. So use this one and substitute the d value and n value. So d value is 0.4 and n value is 1450 by 60. So u2 value, you got the value 30.36 meter per second. That is the speed of the blade at outlet u2 value. And the second value you have to calculate, that is vw2 value. So to find this vw2 value, direct formula is not there, so you have to utilize this velocity diagram only. So by using this velocity diagram, pi value is given and vf2 value is given. So by using these two values and using the formulas of triangle formulas, you can write the tan pi. So this is the pi value, tan pi equal to opposite by adjacent one. So this value is the difference of the u2 minus vw2 value. So taking those combination, tan pi equal to vf2 by u2 minus vw2, So take this parameter to this side and this one to that side. You will get u2 minus vw2 equal to vf2 by tan pi. And then from this once again separate the vw2 value. So vw2 is equal to, it is in minus sign, so take this one to the other side and this parameter to left side. You will get vw2 equal to u2 minus, when it is taken to this side, minus, and when this parameter taken to the other side, minus will become plus. So that is why vw2 equal to u2 minus vf2 by tan pi. And substituting the u2 value 30.36 meter per second, vf2 by tan pi, vf2 value is given 2.2 and tan pi value is given 30 degrees. By substituting all these values, you will get the value 26.55 meter per second. This is the overall vw2 value by using the formula from the velocity, outlet velocity triangle. Next, so we got the values of vw2 and u2 value, and manometric efficiency also known for us. So using from this relation, you can rewrite the formula manometric efficiency equal to GHM by vw2 u2. So from this, take out the HM value to one of the side. So we will get manometric efficiency into vw2 u2. Manometric efficiency, when it is comes this side, it will be a multiple of this one. So vw2 and u2, and g value comes to denominator. So manometric efficiency into vw2 u2 by z. So substituting manometric efficiency, vw wheel velocity and blade velocity and gravity values, you will get the head developed is equal to 61.62 meters. So first value is head developed. So this is the total head developed by this pump, that is 61.62 meters. Now come to the second one, absolute velocity at outlet. You have to find the absolute velocity at outlet. So this value you have to find. So for you finding this value, just use the right angle triangle, and hypotenuse square is equal to sum of the squares of the other two sides. So v2 square is equal to vw2 square plus vf2 square, using that relation. H square is equal to a square plus b square, like that. So v2 square equal to vw2 square plus vf2 square. From this you can write the v2 value is equal to under root of vw2 square plus vf2 square. By taking this square to the other side, it will become under square root. And now vw2 value is known and vf2 value is equal to vf1 value. So substituting those two values in this formula, you will get v2 value, that is absolute velocity value is 26.64 meter per second. So second value is also you got. And next finally is asked to find the blade angle at inlet. So blade angle at inlet. So blade angle is theta value. So to find this theta value, use the one of this side and other side. So this side by this side is nothing but the tan only. So tan theta equal to Vf1 by u1. So you can write that relation tan theta equal to opposite by adjacent, Vf1 by u1. So u1 value is unknown value, so find the u1 value by using the formula, that is u1 is equal to pi dn by 60. Substitute d value and n value. D1 value is given 0.2 and n value is 1450 by 60. You will get the u1 value 15.18 meter per second. That is the velocity of the blade at inlet. At this point the blade velocity or impeller blade velocity is 15.18. Always u1 is lesser than u2 value only, because at this point diameter is these velocities are proportional to the diameter. If diameter is greater, then the velocity at those points is also greater. That is why at this point u2 value is always greater than this one. That is why only the line of u2 value is longer than the line at this point. So u1, you got the u1 value 15, and now substitute the values in this formula. Tan theta equal to Vf1 by u1. Vf1 value is 2.2 and u1 value is 15.18, and from this you can get the theta value is equal to 8.2 degrees. So in this way you have to solve the different types of the problems based on the centrifugal pumps. Thank you.